Okay, so here we're going to do choice exercise 10 from homework 3. We have two random variables. The first random variable is x, which has this PMF, which is given by some binomial coefficient times something else. We're later going to describe this. We want to be able to recognize this pattern, that this is saying that x is distributed like binomial with n equals 10, and our chance of success being 2/3. And y is a random variable here with a PMF given by this thing. This is very close to geometric, except for it's defined a very slightly different way, which is that if we have a coin that lands on heads 20% of the time, y isn't the number of flips like we usually do when we're talking about geometric. This is kind of a different definition, a slightly different kind of geometric definition. Instead of y is going to be the number of tails. Okay, so we could have 0 tails if we get a head on our first try. And then in R, we have two implementations of these two probability mass functions for dbinom and dgeom, and the R dgeom is a little bit different than the one we do in class, which reflects this kind of slightly different story we're telling about it. Okay, so A asks, what's an example of an experiment that can be modeled with A? Here I'm going to say we flip 10 coins. Each land on heads with probability 2/3. X is the number of heads. Okay, next I want to guess at the probability that x and y equal 10 if x and y are independent. I'm going to make I don't remember the answers. I'm going to make an honest to God my best guess here. I'm sort of expecting that typically we're going to get our head on average on the 5th try. So we're going to get sort of 4 tails on average. And on average, our x is going to be 2/3 times 10. That's the proportion that we expect. So this is actually going to be like one of the more frequent occurrences. Like 10 isn't a super rare thing I would expect. So I'm just going to kind of ballpark it. There's lots of things going on. 10's a big number. My guess? Somewhere maybe in the ballpark of 20%, 15%. I don't know. I could be quite wrong here. Let's go with let's split the difference. Let's go with 18%. Okay, and next what we're going to do is we're going to use R to compute this, but I want to talk about how we're going to compute it before we jump into R. So how could x plus y equal 10? Well, we would need a couple of things to happen. Either we could have a situation where x equals 0. We got really weirdly unlucky. We got all 10 tails, even though we don't usually get tails. And then y equals exactly 10, which is then when we flip these coins, we get 10 tails in a row. There's lots of tails going on here before we get a heads on our 11th try. Or we could get 1 head over here and 9 tails in a row, or 6 tens over here and 4 tails in a row, or so on. But the idea is that it's going to be equal to the PMF of x being equal to 0 times, since this is independent, this is going to be the PMF of y being equal to 10. Super unlikely situation. But slightly more likely, still really rare, is that x equals 1 while y equals 9. That will also add up to 10. Then x plus y equals 10. All of the way up to PMF of x being equal to 10. We get all heads. And then for y, we get no tails. We get a heads on our first flip. Okay, and so we're going to implement this in R. It will be really quick will be a one-line thing. Okay, so here again, what's the idea? We're going to do this PMF x of 0 times PMF y of 10 plus, now here x equals 1 and y equals 9. That adds up to 10. And then lastly, we're going to make it all the way till x equals 10 and y equals 0. Okay, and so here's what I want to do. I want to first do the PMF of 10, which is, as it mentions in the problem, this is d binom. Here are our x values. They're going to go from 0 to 10. Our size is 10, and our probability is going to be 2/3. Okay, and then so that's a certain vector, and then you can see the results down here. It's sort of its biggest somewhere hanging out around 2/3, so 6 or 7, something like that is the biggest. And then we're going to have d geom. And here I actually want to count down backwards. So this is going to be our different values that we could see here. Okay, so if we're landing on heads with 1/5 of the time, then there's a 1/5 chance that we get a heads on our first try, and a 16% chance that it happens on our second try, and so on, which means we'd have 0 tail, 1 tail, all of the way up. This refers to 10 tails. And now I just want to multiply these, and it turns out if you multiply vectors, the way that R defines it is it just does a pairwise multiplication. Okay, and now we can add this up, and we get that the answer is just about 10%, 10.03224%.